Hi, this is an introduction to one of my very favorite labs. It's the determination of an empirical formula. I like this lab because it's one of the first wet labs we're really doing, which involves a lot of chemicals, chemical reactions, and thus some safety concerns. Well, in this lab we're going to take some tin, atomic number 50 on the periodic table. The tin comes in a granular form, 20 mesh, very small round pellets. So you don't want to be measuring them on the balance on a piece of paper. You could use a weighing boat. That's a very good option. But something even better might be to use the evaporating dish that you'll be using in the experiment. What you want to do is tare the balance to 0, mass, and record the mass of your evaporating dish. You'll need it later in the lab. Then tare out the mass of the dish and add 2 grams, as close as possible, of tin to the evaporating dish. If you only add 1.95 grams, that's the amount you should record. The second reactant is going to be nitric acid. Concentrated nitric acid is 16 molar. Nasty, nasty, nasty. But what we're going to be using is a 1-to-1 dilution. And so it's actually 8 molar. I'll be pipetting 5 milliliters of 8 molar nitric acid into each of your evaporating dishes containing the tin. This will then be sitting upon some wire gauze. Make sure that the wire gauze is stiff and firm so that you can do this experiment safely. Alright, so what are we going to do now? You should have a partner working with you. The partner's job is to control the Bunsen burner. You know, when we put the Bunsen burner under a mixture of liquid nitric acid and tin, not good. What we want to do is we want to let the reaction mixture start. For this, we want to be sure that we have our goggles on. The goggles are clean and on our eyes. Now, we see the reaction mixture starting to occur. Then we start to see a reddish brown gas appearing. In my experience, any gas that has color and I can see, not good. It will harm you, especially if it gets in contact with any moist surfaces like your eyelight, like your eyes, your nasal passages, your mouth, sweaty skin. Not good. So what we're going to do as soon as we see that starting to occur is we'll take a watch glass, one that sits right on top, it doesn't go down into the evaporating dish, and cover the dish so that it will contain a lot of the fumes. If you have the possibility of doing this in a hood, you should do so. Your teacher will talk to you about that. The reaction mixture needs to go to completion, so we all go out the door. We'll go to lunch. We'll be gone for about 30 minutes. The reaction mixture goes to completion, and upon return, we're ready to get started. We're going to take the watch glass off of our dish, and what we're going to do now is use the Bunsen burner to evaporate our reaction mixture to dryness. We want to know the mass of our new product, and all the liquid that remains will not allow us to mass it correctly. So we have to heat gently. Now if you're heating this liquid, it's going to start to pop and bubble and boil. You can't leave this under an evaporating dish. I would suggest that your partner moves this around a little bit, and when it starts to bubble, pull the Bunsen burner away. Alright, come back a second later, a little heat, away. A little heat, away. If you heat too much, this is going to pop like popcorn. The water trapped inside these particles will expand into the vapor phase and poof, everywhere. Your mass will be on the counter, on your clothes, on the floor, everywhere. That's going to give you a lot of error. What will the second person be doing? Using your strongest hand I'm right-handed, so I'm going to hold the tongs in my right hand. I want to grip, and you want to be very careful. Some of the older tongs, whenever you actually close up the tongs, what happens is that they push past each other at the tips, and they will not even hold the dish correctly. So make sure that your tongs close on the dish, and that they're not closed too far down in the dish, and that what you're going to do is take the dish, hold it here, and as your partner starts to heat, you want to stir the reaction mixture. Now, you have a plastic stirring rod, bad idea. Over the heat, it's going to melt. You'll get a lot of debris in your sample. Your masses will be poor. What you want to do is use a glass stirring rod. Now, what do you want to do, or how will you use the glass stirring rod? Well, you want to stir. You want to break up any particles that you see. You want to constantly push the products down off the sides and lower into the dish. You may get some of the moist product sticking to the end of the glass stirring rod. Don't worry about it. If you keep heating, there will come a time when it will be dry enough that you can take this and roll it along the sides of the evaporating dish, and it will fall off into the dish so that you can include that in the mass of your product. The main thing is hold this dish carefully and tightly. You're going to stir it until your powder, until your product has the consistency of baby powder. Any particles that you can see are being held together by moisture, and that moisture has got to be removed. So you want to constantly pound and break up those particles, making sure that there's no moisture left to hold those particles together. When you think you're done, this is going to take at least 10 minutes. I would suggest 15 or more if you have it. Then what you want to do is move your evaporating dish to the counter where it can cool off. There are some hot pads in the room. If you take and put your watch glass, your evaporating dish, on the hot pad, it's going to burn right through. You're just going to use this up below the evaporating dish in case you drop it. Put this on the counter, step away and let it cool off for about 2 minutes. After 2 minutes, you would mask the evaporating dish. Now, of course, I've already got one on there. You take the evaporating dish, and of course its mass is going to be lower because you've driven off some water. The question is that all the water that's been driven off, or just some of it? You've got to check. So even though you have a preliminary mass for the dry 10 oxygen compound, you're going to take this dish, return it to the source of heat, hold it carefully with the clamps, and as your partner heats again, stir and break up the particles. Upon the second heating, you want to remove it again after you heat for 2 minutes. This is all in the lab write-up. After 2 minutes, you'll remove the dish to the counter, cool again for 2 minutes. After 2 minutes, you will weigh it on your balance, and if the mass changes less than 0.02 grams, then you've had very little decrease in the mass, and you can assume that the mass of your sample is constant, that you've driven off all the water. Now, there's probably a few other tips that we want to share with you before you start the lab, but just having this already in mind, I think you're going to do a much better job in the lab and get much better results. We're looking for the empirical formula, so we're going to have to take our masses, go to moles, and find our smallest whole number ratio. How many possibilities are there? Are we making a pure product? How can we control making one product rather than the other? Lots of good questions for you to consider.